volumes. Now, coming to the storage part of the story, we have already discussed about that. We have two different kind of storage we can consider within a pod or within a container when it runs within a pod. One is ephemeral volume, which is commonly known as volume, and another is persistent volume, which is for long-term storage. Fairly simple, right? So when you don't need to care about the local storage, you put it in the ephemeral volume, which is short-lived. When you care about the files getting added or modified in the storage, and you need to retain it even if the pod goes down, you use the persistent volume. Now, what happens when the Kubernetes pod gets created, right? It basically hosts a container within that pod, right? Which may need some sort of storage mechanism. The images are generally mounted on the root of the file system hierarchy on each container, right? When a pod gets created, and then volumes are mounted at specific path within that image to any or all the containers. So what happens when you select an appropriate storage type, and then you say that, hey, I want to have a file share, and this is my file share folder. Let's map that drive to the container. You can do that, right? So you can map the path and then have that collected. The Kubernetes volume are the most basic storage unit, right? It basically links the storage to the pod and disassociate it from the container, which means that you can run one or more containers within a pod, and you can have one volume mounted to that pod, and then use that mount volume as the storage for both the containers. So what happens if you have a backend system which brings the file from an external system and stores into local storage, the other application can pick it up from that local storage, totally local experience, because they are both are within the same pod, right? So they basically can interact locally using the local host, and they have the same file share or the map drive, which can actually read the value from there. Now, you can actually think about it in three different ways. So one is data supported by volume in the pod file system that is persist if one of the pod container crashes and restarts, right? Second scenario is that data is shared between containers, as we discussed earlier. And if it is in the single pod, multi-container scenario, you can achieve that. And you can get a single volume and then apply to all the containers within that pod. A third scenario is that the volumes are defined in the context of the pod, right? And then volume becomes unmanageable and life cycle is tied to the pod. So the moment pod is somehow deleted, if it is behind the deployment will create the pod. So you essentially lose that volume because this is part of the pod, right? You can also think about deleting the pod manually. So if you delete the pod, everything is deleted, right? So even the volume is also deleted. Now, the Kubernetes volume, as we discussed earlier, classified based on their life cycle. One is ephemeral volume, another is persistent volume. Now, if you think about the ephemeral volume, it is basically in the node. So actually within the Kubernetes cluster, you have the virtual machine or physical machine as worker node, right? That's where this is, right? So you create an empty tier, it will be created in your node. Okay, if you create a host path, it will be created in your node, and that is what getting used by the pod you are creating, and then map it in the pod, and then finally being used by the container, because pod can't do anything with the volume, right? It is the container, and inside the container the application code which is going to go ahead and use that volume, right? So you basically have that folder created somewhere in the node machine, and then say that pod that, hey, use this path to store the file. And then in the pod, you basically have those things. Now, what happens when you have this kind of storage? If the pod is deleted and recreated in some other node, you tend to lose that. So it's also sometimes risky. Now, to avoid this kind of thing, we use something like persistent volume. Now, persistent volume is not necessarily always part of the cluster. It can be an external storage like cloud volume. let's say any public cloud storage mechanism, which provides you the file share sort of services, you can use that. There are plugins available to attach it with the Kubernetes persistent volume. You also have network file systems thing, which essentially allows you to use the iSCSI or NFS sort of thing. And then you can attach the specialized storage component with your persistent volume. And you can also use persistent volume claim, which is something very interesting because it basically creates a space in the cluster. It's a cluster object. The persistent volume is a cluster object at the end of the day. And then the persistent volume claim actually does a handshake with the persistent volume and gives you an ability to use the persistent volume claim with your pod. So you don't use the persistent volume directly, rather you use the persistent volume claim when you create the pod. So you attach that persistent volume claim, it at the back end gets the persistent volume handshake and gives you a space. If the persistent volume is somehow deleted or removed, it'll wait for another persistent volume to match the criteria and then attach it again. So it constantly work on that perspective to make sure that your data is safe and secure. Now there are different kind of like volumes you can work with in Kubernetes, right? So you can see there are a bunch of them available and you can actually use depending on the typical use case. Now we'll talk about Kubernetes config maps. The Kubernetes config maps and secrets are the way to provide additional information, configuration information for the application. Now, when you package an application in a container, that application may be talking to a database. Now, it expects a database connection string. Now, that connection string can change depending on the deployment we are making. So, if you make a deployment today for a customer one in their environment, the database information is completely different than if you put it in another customer location. So, that has to be dynamic. Now, how do you supply that? We supply them generally using environment variables, right? So we say that we'll have environment variable with a connection string, and that will be picked up by the container because it's within that container, and then it'll work. Now, how do you load that environment variable? Because you already have the container images ready, right? Now we use the config map concept to push those environment variables inside the system. Now config map can also be loaded as a drive, as a file, as an environment variable. There are many different ways it can be loaded. Same thing happens with secret. So let's see what happens. Now, if you have a config map, this is a key value pair to store the non-confidential data, mainly the plain text. So maybe you want to have some non-sensitive information, generally the environment variables, which are generally non-sensitive information, right? And then it allows you to decouple the environment-specific configuration from the container image. So you don't have to bring everything inside the container image. You keep the placeholder within the container image, say that I am going to read these keys and these keys will come from environment. The value will change and then we use the config map to push those values in that. Config map can be manually written using YAML. So you can use the YAML to generate the config map. You can also use kubectl to create a config map from the command line. So either way, it works. Now, what happens when you have the config map? You design an app that can be used both on your personal computer or in the cloud. Now, you see that we have a database host, which is basically the environment variable, which has the database information, right? So you in the cloud, you have to configure to refer the Kubernetes service as you expose that in the database component. In the local, it'll be different. So how do you provide that? You provide that using config map, right? So you can actually use that config map to load the data either in a volume mount or in an environment variable. And the config map size is limit up to 1 MB because it is a simple text, right? 1 MB is a lot of space. So you don't have to really worry about the limit here because it's negligible, right? In terms of just considering the thing. Now you can see that you are going to create a config map through YAML, right? You give a name and then you have the data. And this is where you have a multi-line information. Now, in YAML, when you have multi-line, you use this pipe command. It means that you are entering multi-line value. Now, if it's single line, it ends here, and then another property starts in the next line. So that's a single line concept. But the moment you have multi-line property, you just basically use this pipe and then put in multiple lines. You see there, that's what it is adding. So game properties, user interface properties. So all of them coming and going to create as a config map over here, right? Now, config map is a free text. It's unencrypted or on, let's say, it's a plain text. So what you read is what you see, right? So there is no secret behind it. So you just kind of like have an open text thing. Now, secrets on the other side is to hide the sensitive information. It is not encryption, by the way, just to make sure that we understand this. This is not an encrypted text. It is a base 64 encoded text. There are two differences because encrypted text, to decrypt it, we need to have that cryptographic public key with us or private key with us. However, for the encoding, we can use simple Linux command to decode it, right? So that may not be readable for the end user, but by doing a decryption, you will be able to read it, right? So that's the thing about secret. So it's just immediate, just to not to make it so obvious, but you hide it, right? That's not the ultimate way. So if you have really sensitive information to store and read from, you should consider external key storage mechanism to store things, right? So Kubernetes secret is not foolproof in that sense. So you can think of storing simple password, OAuth tokens, SSH keys, right? And you can define in the pod specification or an image specification, right? You can create it by yourself, or system also can create certain secrets for you, which is being used on regular Kubernetes object creation. Now, secret types are specified using the secret resource or the line flag. So you can actually create secret couple of different ways through the kubectl command, right? And then you can also use a life cycle of the secret if you are constantly replacing the secret with a new value. So for example, if you have some secret, you just need to replace it, you can do that because um, typically for things like certification or token, which is not a permanent thing which keeps changing, you need to do a refresh. All right, you need to do those refresh mechanism. Now there are different kind of secrets like opaque, and then you have other things. So you use the secret accordingly based on the requirement. Now, just an example of the secret, right? If you say that whatever the password you provide, and pipe base 64, it'll be encoded, and that's what the secret would look like. Now you save this output, right? And then create an YAML file with that value. So you see that it is base 64 encoded, right? So you provide that information in the YAML file, which is a database password, okay? And the type is opaque. Now what happens? You get the secret as an object within the Kubernetes, which you can use when you create the pod, and then the container will be able to use this information as one of its key if you load that. Now you can also create the secret using the YAML file. So if you have this YAML file created, you can do that. You can even use the kubectl command line interface to create this secret.